So for the second half of problem 18, part F, I want you to verify Kirchhoff's law again. So E is going to be equal to the voltage drops. We found this to be E, and this is the voltage across a resistor, inductor, capacitor that we found earlier. You have to convert this to polar form, and it's, the first term is the magnitude times the cosine of this angle plus J times the magnitude times the sine of this angle. That's actually a 0.86. That's a flaw in the book, but the other answers are right. And then when you combine all these terms together, you add the 0.822 to the minus 0.822 to the minus 1.44 plus 4.38, and you get 2.12 plus J, and then you add the 0.86 minus 1.37 plus 4.19, and you get a 3.62. And then when you convert it back to polar form, what you do is you take the square root of 2.12 squared plus 3.662 squared. It gives you 4.20. And then the angle is the inverse tangent of 3.620 divided by 2.12, which equals this, which is really close. Probably it would have been even closer if they had gotten that 0.86 right. Part G is find the average power, and again it equals P equals I squared R, because the capacitive and then the inductive components don't dissipate any power. So you take the value of I, which was this magnitude 0.993, you square it times 0.12K, which was the value given for R, and you get 1.18 milliwatts. Power factor is R over ZT again, 1.2K over 4.27, which is what when we found ZT right here, that magnitude, and it's 0.281. And the reason why it is leading is because, again, the only way you're going to know is you have to compare E and I. So E is 60, I is 133. So theta I is greater than theta V or E. So you know that the current leads the voltage because this number is greater than that number. That's how you know that's leading. And then I is equal to the value of I here, 0.993 times the square root of 2, which is 1.4 times 10 to the negative 3, sine of 20,000 T plus its phase angle, 133.69. And likewise, V sub R is going to be this 1.19 times the square root of 2, 20,000 T with its phase angle, and then V sub L will be 1.99 times the square root of 2, which is 2.81 times the sine plus its phase angle. V sub C is going to be 6.06 times the square root of 2, which is 8.57 sine omega T plus its phase angle.